we start to learn the chapter 7. That's proportion. So first, we need to learn the section 1, direct proportion. So what is a direct proportion? That means when one is small, another also small. When one become bigger, another one also become bigger. Okay, suppose we have two variables, x and y. If x equals 1, when x equals 1, y equals 2. Okay, now let me show you. If x equals 1, then if x equals 1, then y equals 2. But when x equals 2, y will equals 4. Okay, so that means the ratio of x over y, this one keep to a constant. See, that means a constant. For this case, that's equals 1 over 2. This is called a direct proportion. So when x become bigger, y also become bigger. And also for the same ratio, x over y always keep equals 1 over 2. This is called direct proportion. Okay, so now let's see some examples. Use a direct proportion, we can solve some problems. Now let's see example 7.1. If x and y are directly proportional and x equals 5 when y equals 9, then what is y when x is 14? Can everybody do this? Give me an answer if you have it in the private chat. So when x equals 5, when y equals 9, x equals 5. Then when x is 14, what is y? Can everybody do this on your scratch paper? Then send me the private chat of your answer. Then now let me check. Say here, when x equals 5, y equals 9. Then x equals 14, they ask you what is y, right? They call this one the direct proportion. Direct proportion, I just tell you the ratio of these two variables keep is constant. So that means x over y always equals 5 over 9. Okay, so then if x now equals 14, say they give you now if x equals 14, what is y? So then that means you get the equation is this: 5 over 9 equals 14 over y. Then you need to solve y. You just do cross multiplication. You got a 5 times y equals 9 times 14. So then that means y equals 9 times 14, then divided by 5. So 14 times 9, 126. Then over 5. Now if you write this one to a mixed number, that will be 25 and 1/5. Okay, Anderson, you got it correct. Okay, this one's correct, this one's also correct. You can also write this one as improper fraction. Okay, this is the correct way to do this. because they tell you this is a direct proportional. So that means the ratio of these two variables keep it's a constant. So x over y equals 5 over 9. This one keep constant. Then when x equals 14, they ask you find y. So then that means we can get an equation that's 5 over 9 equals 14 over y. Then you solve y. You get y equals 9 times 14, then divided by 5. Okay? So this one is A. Now let's do B. If A and B square are directly proportional and A equals 5 when B equals 9, then what is A when B is 12? So say first they give you this one's proportional. Then A equals 5, B equals 9. Then they give you B equals 12. Then you ask you what is A. Okay, everybody do it. Then send me your answer. Direct proportion. So that means the ratio is constant, right? So then that means A over B, that's equals 5 over 9. Okay, this is A over B. So that means A over 12 equals 5 over 9. Then you solve A. Solve A from here, you do cross multiplication, you get 9 times A equals 5 times 12, that's 60. Okay, then you get A equals 60 over 9. Now you need to simplify. You need to check, yeah, 60 and 9, they have a common factor 3. So we cancel out that. Got 20 over 3. Okay, this one's correct answer. Okay. Got it? Jasmine, did you got it?
Yeah.
Okay, you need to send me an answer. Don't just keep there, do nothing. Okay, now let's go to next problem. So this one, Jasmine, can you read this problem?
Mary is 5 feet tall and her shadow is 12 feet long. The flagpole she is standing next to casts a shadow that is 42 feet long.
Continue to read A.
What is the ratio of the height of an object?
Of an object to the length of its shadow. Use the information to find the height of the flagpole. Okay, so now let's say first you need to draw a picture help you to understand this problem. She said Mary is 5 feet tall. Mary is 5 feet tall, and her shadow is 12 feet tall, 12 feet long. Now the flagpole she's standing next to cast a shadow that's 42 feet long. So suppose this is a Mary standing here, then this one suppose that's 5 feet, then the shadow is like this. Okay, now let's see this. This is a shadow for Mary, that's 7 feet. Okay, is this part. Then they have a flagpole. She's standing nearby, that's 42 feet long. Then they ask you, what is the ratio of the height of the object to the length of its shadow? So, Jasmine, can you answer this question? What is the ratio of the height of the object to the length of its shadow? Jasmine, are you there?
Wait.
What is the ratio of the height of the object to the length of its shadow?
Is the object Mary?
Yes.
I'm confused. I got disconnected.
Yeah. See, the height of an object to the length of its shadow.
So is it 5 feet to 12 feet?
No, to
Wait.
7 feet. See, they give you the shadow is, oh, this is 12. Oh, I'm sorry, you're right. Give me a sec. This is the 12, it's not 7. Okay, I'm sorry, this one's 12. So that's 5 feet over 12. Yeah, you're right. That's the ratio. Okay, so then B, the flagpole's shadow is how many times as long as Mary's shadow? Use this to find the height of the flagpole. Okay, so then they ask you the flagpole's shadow is how many times as long as Mary's shadow? Okay, so you can see they give you the flagpole that's this all. I also marked this one wrong. The 42, that's the shadow of flagpole. That's 42 feet. So then, what is how many times as long as Mary's shadow? Flagpole's shadow, that's 42 feet. The Mary's shadow, that's 12 feet. So the ratio is 42 over 12. If we simplify this, that will be 7, this one will be 2. So that equals 3.5 times as long as Mary's shadow. Okay? So use this one to find the height of the flagpole. So then you just use 5 times 3.5. That's you can also write this one 7 over 2. So you got that this one equals 35 over 2. So this equals 17.5. So that means height of flagpole, that's 17.5 feet. The shadow of flagpole, that's 42 feet. Okay? See, this one, it's also a direct proportion, right? So you can do this way. The height, the flagpole, suppose that's x. So 5 over x equals 12 over 42. Okay, then you solve this equation. So you got x equals 5 times 42, then divided by 12. So simplify their common factor, 6 between 12 and 42. You got this one's 2, this one's 7, so 35 over 2. Then you got this one equals 17.5. Okay. Now let's go to next problem. Max, Are you there? Max,
Yep.
can you help me read this problem?
Okay. Dr. 2 must administer emergency medicine to his patient, Mrs. Jones. The instructions on the medicine state that is a 140-pound person must receive exactly 100 millimeters of the medicine, and that patients of different weights should receive a proportional amount of the medicine. Mrs. Jones weighs only 120 pounds. How many milliliters of the medicine should Dr. 2 administer to Mrs. Jones?
Okay. I give everybody 1 minute to solve this problem. So this one still is a direct proportion. So then they ask you how many milliliters of medicine should Dr. 2 administer to Mrs. Jones. You know, for a 140 pound of person, they can get exactly 100 milliliters of medicine. Now, Miss Jones only 120 pounds. Then they ask you, what is how many milliliters of medicine Miss Jones should take? So then you get this equation, right? Then you solve this equation. Now let's cancel out the common factor. So this one that will be 5, this one will be 7. So then we get x equals 120 times 5, then divided by 7. So it's give us 600 over 7. So then this one, you can also write this one, it's an improper fraction. You can also convert this one to a mixed number. So if we try to convert this one to a mixed number, that will equals 8. That's 56, right? Then have 4 left, 40. So you put 5, 35, then 5 over 7. This one is a mixed number. That's the milliliters, ml. Okay, you can also write this one, 600 over 7 milliliters. Okay, so this section, that's what we learned. It's direction proportion. Okay, that's very easy. Oh, actually here we did something wrong here. Now let's see. This one's a and b squared are directly proportion, and a equals 5 and b equals 9. Then what is a when b is 12? So then you need to be careful. This one is not b, it's b squared. So that means 5 over 9. This one's a over b. But then tell you a and b squared are proportional. So then you need a square of this 9. This one equals 12 square then a. You need to solve this equation because they tell you a and b square are direct proportion, not a and b. So then we can solve this equation by 5 times 12 square, then divided by 9 square. So then you can cancel this one. You got a 4 times 4, that's 16. 16 times 8. 16 times 5, that's 80. Then divided by 9. Okay, a will equal this number. If you write this one as a mixed number, that will be 11. Let's see, 8 and 8 over 9, right? So this is A. Okay, so then now we can check this answer. You can see here. Yeah, this is A over B squared. Okay, A over 12 squared. That's 144 equals 5 over 81. That's 9 squared. Then you solve A, got a 80 over 9. Okay, so this is a direction proportion. This is a very easy. Now let's see another kind of proportion called inverse proportion. So what is the inverse proportion? That's exactly opposite with the direct proportion. You know, direct proportion, that's when one variable become bigger, another one just also become bigger. But the inverse proportion, that's when one become bigger, another will become smaller. When one becomes smaller, another will become bigger. So in this case, if they have their products equals a constant, okay? Suppose when x equals 1, y equals 10. So 1 times 10, you got a 10, right? So if x equals 2, then y equals 5. Then 2 times 5 also equals 10. So this one called inversely proportional. So that means the products of these two variables keep a constant. We call these two variables are inversely proportional. So now let's see example 7.4. If P and Q are inversely proportional and P equals 7 when Q equals 24, then find P when Q equals 12. So first, they tell you here P and Q are inversely proportional. So that means P times Q equal a constant. So then they give you P equals 7, Q equals 24. Now they give you Q equals 12. They ask you what is P. So then you can get the equation that's 7 times 24. This product should be kept same when the 12, Q equals 12. So 12 times P. So then we can get this one, that's 12 times P. Then you solve this equation, you get a P equals 7 times 24, then divided by 12. So you got this one equals, cuts out 2. 7 times 2, you got a P equals 14. So we found P equals 14. The ratio we're using here, the product of P and Q keep the constant. So when P equals 7, Q equals 24. Therefore, 7 times 24 equals 12 times P. Therefore, P equals 7 times 24 divided by 12. Therefore, P equals 14. Now, B. W squared and Z cubed are inversely proportional. And W equals 3 and when Z equals 12. What is Z when W equals 6? So first, you need to be careful. This is the proportional, inversely proportional. And also it's W squared and Z cubed. It's not W and Z. Okay? This one you need to be careful. Now when W equals 3, Z equals 12. So then we need to get W squared, that's 3 squared times Z cubed, that's 12 cubed. This one keep constant. And equals W equals 6, so 6 squared times Z cubed. Okay, you got this equation. This show you W squared and Z cubed. They are inversely proportional. Okay, then you solve Z cubed from this equation. So Z equals 3 squared times 12 cubed. Then divided by 6 squared. Then you need to take the power that's 1/3, because this one is Z. You know, first you can set this two step. First find Z cubed. Z cubed will equals 3 squared times 12 cubed, then divided by 6 squared. So then this one cancels out with this. You got left this one's 2 squared, because 6 equals 3 times 2. So then you cancel out this. Now let's see, we write 12 times 12 times 12. That's cube of 12. Then divided by 2 times 2. So cancel out this. Then we can get this one, it's 3. So then we can write this one equals 3 cubed. Then times 2 power, say, there will be 4 times 4. That's 2 power 4. Okay? Then you got a Z will equals 3 times 2, then times 2 power 1/3. That's cubed. So you got this one equals 6 times 2 cubed. Okay? This is the answer for Z. Okay? So the key point, you need to first make sure what kind of proportion you have. If you have inversely proportion, then that means the products of the variables equals constant. Then you need to be careful what is the variables here. This one say W squared and Z cubed is not W and Z. So you need to be careful of this. A lot of times the students will forget. Suppose that's W and Z. That's actually will give the wrong answer later. Okay? Then you write down an equation based on the information you get from the problem. Now let's see 7.5. Say this problem is 12 people together can clear a field in 18 hours. In how many hours could 9 people have cleared the same field? Assume that all people clear a field at the same rate. Okay, 12 people together can clear a field in 18 hours. Then in how many hours can 9 people have cleared the same field? Okay, say here they did not tell you what kind of proportional you have here. Then that means you need to determine by yourself. You need to understand this problem. So say if a same job, if the more people do it, then the hours need for each person will be smaller, right? So the total hours for that job will be fixed, right? So suppose we try to build a house. Then if the total hours for build a house, suppose that's 100 worker hours. Then if we have 10 hours, 10 workers, then we need 10 hours, right? 10 times 10 give you 100 worker hours. But if you only have one worker, so that means you need 100 hours for that worker, right? So that means here the number of people times the number of hours needed for each worker, this one should be kept the same, because this one is the total hours of worker hours needed for this job. So see here, 12 people together can clear a field in 18 hours. So that means if you want to clean this field, you need 12 times 18 worker hours. So now they said, in how many hours could 9 people have cleared the same field? 9 people. They ask you how many hours you need for these 9 people to clean the same field. So that's 9 times h. Suppose that's number of hours we need for these 9 people. So then we can solve this equation. That will be h equals 12 times 18 divided by 9. So then we cancel out this common factor. Get this one equals 12 times 2 equals 24. H equals 24. So that means you need 24 hours for these 9 people have cleaned the same field. So this one makes sense. Say, if you have fewer workers, then definitely you need a longer time for these workers to finish this job. If you have more workers, definitely you need to have fewer hours for this worker to finish this job. Okay, so that means the number of workers and the number of hours, these two variables are inversely proportional. It's inversely proportional. Even they did not tell you that relationship in this problem, but you need to know that's inverse proportional. Okay. Now let's see the next problem, 7.6. Prove that if positive numbers x and y are inversely proportional, and y and z are inversely proportional, then x and z are directly proportional. Okay, so in American math education, they seldom teach students to do proof problems in the middle and high school. This one you need to learn how to do this, especially when you go to the math competition, high-level math competition, like math Olympiad. This kind of competition, usually there's a lot of problems ask you to prove. Then also when you go to college, especially if you try to learn math, in the math major, most problems they ask you to prove. You don't need calculate. Calculate, sometimes you still need to calculate, but most they like you to prove. So now let's see how we can prove this. Say, if positive numbers x and y are inversely proportional, so based on the inversely proportional definition, we can get x times y equals a constant. Suppose that's equals c. Then y and z are all inversely proportional. So that means we can get y times z. This one equals a constant. Suppose that's equals k. Then they ask you what is the relationship between x and z are directly proportional. So now let's solve x from this equation. We get x equals c over y. We can solve z from this equation. We get z equals k over y. Now from this two, now let's find what is the relationship between x and z. So we can do x over z. This one equals c over y divided by k over y. This is the division of two fractions, so we can convert this one to multiplication of fractions. So that's equals y, because change to multiplication, then you need to find the reciprocal of the second fraction. So that will be y over k. So y and y cancel out. So you got this one equals c over k. You know, c is a constant. K is also constant. So that means c over k is also constant. Then that means the ratio of x and z is a constant. Based on definition of directly proportion, we can get x over x and z are directly proportional. Okay? So based on the definition of directly proportion, we can get x over z are directly proportional. That's what you prove, right? You prove because x times y equals constant. Y times z equals another constant. C and k can be different, also can be same. Then from x times y equals constant, you get x equals c over y. From y times z equals constant k, you can get z equals k over y. Then the ratio of x over z equals c over y divided by k over y. Then this is the division of fractions. You can convert this one to multiplication of the fractions. You get this c over y times y over k. Cancel out the y, then you get this one equals c over k. So c is a constant, k is another constant. Therefore, c over k is also constant. That means the ratio of x and y is a constant. Then based on definition of directly proportion, x and z are directly proportional. Then we proved. Okay? So by this way, we finished the second section. Now let's go to third section. Joint proportional. What is a joint proportional? Joint proportional is a combine of directly proportional and inverse proportional. Okay? Usually it have three, more than two variables. Okay? So you can say in the physics or the chemistry, we have ideal gas law related to the pressure P, temperature T, and the volume V of ideal gas. The law states that product of pressure and volume equals constant N times constant K times the temperature T. R is a universal gas constant, and N is a measure of the number of the molecules of gas present. As its name suggests, R is a constant. For the following questions, assume that N remains constant. So N and R are all constant. Then we have three variables. That's P, pressure, V, that's volume, and T, that's temperature. Now A, if the temperature of an ideal gas remains constant, how are the pressure and the volume of the gas related? So here you have these three variables. They tell you if the temperature, this variable keep constant. If this one is a constant, then what is the relationship between pressure and volume? Okay, now let me ask Jasmine, can you tell me in this case what is the relationship between pressure and volume? Jasmine? Are you there?
Yeah.
Can you tell me what is the relationship between the pressure and volume? If temperature is constant. So Edward and Edison and Max, can you send me your answer for this one? What is the relationship between pressure and volume if temperature is constant? Say this A. If the temperature of ideal gas remains constant, if this one is a constant, what is the relationship between pressure and volume? If this constant, they ask you what is the relationship between these two variables. Based on what we learned before, if T is a constant, they tell you R is a constant. N is also constant for this case because N is the number of molecules of the gas. So if you did not allow the gas in this volume go out or the new gas come in, then the N is also constant. Okay, now let's see. They're not together. I mean, the relationship between P and V is not together. What is the relationship between between P and V? Yeah, that's a relation. That's a formula. But then, I mean, is there directly proportional or inverse proportional? So Max, you write that formula is correct, but I want to know the P and V are directly proportional or inversely proportional. Okay, inversely proportional. Yeah, that's correct. Okay, so Max, you're right. So now, Jasmine, did you understand? And Edison, you understand? Say if T is constant, the right side that's constant. You can put these three together as a constant C. Then that means P times V equals a constant. So based on the definition of inversely proportional, P and V are inversely proportional. Say because the product of these two variables equals a constant. Okay? Now let's go to B. If the volume of an ideal gas remains constant. So now they tell you if this V keep a constant, how are the pressure and the temperature of the gas related? Then they ask you what is the relationship between this P and this T? Is there directly proportional or inversely proportional? Addison, can you tell me? Addison, are you there?
Yes, I'm here.
What is the relationship between P and T? If V is a constant.
That like, wait, if V is constant?
If V is constant, volume is constant.
Like I think they're interchangeable.
Yeah, so that means V will not change.
Yeah, so like they're interchangeable.
Then they ask you what is the relationship between P and T?
They're interchangeable.
Yeah, P and T definitely will change.
So like, can you change spots with each other? You can just like
Right.
them.
Yeah. So when P change, T definitely will change. When T change, P also will change. The only N, R, and V not change. Then they ask you what is the relationship between P and T. So
like
then
the only ones that like are not constant.
R is constant. R, they tell you R is a constant.
No, I said they're the only ones that are not constant.
R is a constant.
But you asked for one between P and T, not P and R.
P and T, what is the relationship between P and T?
Yeah, I said they're like the only ones that are not constant.
Which one is not constant?
P and T.
Yes,
constant.
Yeah, definitely they are not constant. I will ask you what is the relationship between P and T? Yeah, I know they are not constant. I want to know what is directly proportional or inversely proportional.
Well, that's what I don't know.
Okay, Jasmine, do you know what is the relationship between P and T?
I also don't know.
You don't know? Do you know what is the definition of direct and proportional?
Yeah, kind of, a little bit.
What is that?
It's like if one of them gets bigger, then both of them get bigger in like the same ratio.
Yes, they have the same ratio, right? Suppose you have two variables, x and y. If the ratio of x, y keep a constant, then this one called directly proportional. Okay? If x times y, the product of x and y keep a constant, then we call this one is inversely proportional. This one is inversely proportional. Okay, this one called directly proportional. So here I want to tell me when V is a constant, P and T, they are directly proportional or inversely proportional. To do that, you need to check, is this two variable now product is same, it's equals constant, or the ratio equals constant. You need to check this one satisfy or this one satisfy. So here, if V is constant, now you can get P over T will equals what? Will equals N times R, then divided by V, right? Jasmine, is this one right? say both are divided by t. You got p over t equals n times r, then over v. So n is constant, r is constant, now v is also constant. So this 3 is also a constant. Let's suppose this one equals c. Then by this one tell you, you can show you the ratio of these two variables is a constant. So that means these two variables are directly proportional. P and T are directly proportional because their ratio keep a constant if V is constant. Now let's go to C. Most people are familiar with Celsius or Fahrenheit units for temperature, or both. Why can we not express temperature in these units when using the ideal gas law? So they tell you why in this ideal gas law, the temperature, you don't use Celsius or Fahrenheit. You use, but you use absolute temperature. The reason for this is if we use Celsius or Fahrenheit, the relationship between P and T or V and T, they are not is directly or inversely proportional, because you need to add a constant to T. That one, that's T need to add 273 something. Then that one, it's make this directly or inversely proportional will not exist anymore. So that means this equation will become more difficult. It's not easy to understand. After we use this unit, absolute temperature, then this relationship is very simple. Okay, D. Suppose the volume of a gas is tripled and the pressure halved. How does the temperature change? Okay, so here said suppose the volume of gas is tripled. So suppose volume 2 now equals 3 times volume 1, and the pressure is halved. So P2 equals half times P1. Then how does the temperature change? Okay, everybody, you try this problem. So then you can plug to here. So P times V. So that P2 times V2, that's equals 1/2 times P1 times 3V1, right? Because this one gives us P2 times V2 will equals 1/2 P1 times 3 times V1. So then you got this one equals 3 over 2 times P1 V1. P1 V1 equals N times R times T, right? T, you can, this one, it's times T1, right? P2 times V2 based on this equation will equals N times R times T2, right? So then you compare this one with this. What is the relationship between T2 and T1? So you can do this one over this. you gotta say n times r t2 over 3 over 2 times n times r times t1. This one will equals a ratio that's 1 because say this p2v2, this also p2v2. So then n times r cancels out. So then you gotta use it from this one, you got a t2 equals 3 over 2 times t1. Right? So this one, that means temperature will increase 1.5 times because T2 equals 1.5 times T1, right? So that means, yeah, Max, you're right. T2 is 1.5 times of T1. They ask you how does the temperature change? So temperature increase to 1.5 times of the previous one. Okay. So now let's see next problem. This one said 5 woodchucks would chuck 8 pieces of wood in 2 hours. If woodchuck could chuck wood, how much wood would one woodchuck chuck? If one woodchuck would chuck wood for 1 day, okay? Say this one, you first try to connect the information you can get. Say 5 woodchucks can chuck 8 pieces of wood in 2 hours. Okay? Then if a woodchuck could chuck wood, how much wood would one woodchuck, if one woodchuck could chuck wood for 1 day? Okay? So this kind of problem, that's a joint proportional. So you can say here 5 woodchuck would chuck 8 pieces of wood in 2 hours. So then you need to find each woodchuck can chuck how many pieces in 1 hour. So that means 8 pieces divided by 5 times 2. This one gives you each woodchuck in 1 hour how many pieces they can chuck, right? Now let's calculate this in another way. Say this is one woodchuck can chuck in a whole day. 1 day, that's 24 hours. Then they ask how many pieces they can chuck. Let's suppose that's x. Then you just solve this equation. You can get x, you do cross multiplication. X equals 8 times 24, then divided by 10. Right? So you get this one, cancel out. This one it's 4, this one's 5. Then you cannot cancel anymore. That equals 96 over 5. So this pieces of one woodchuck can chuck in 1 day. Okay, time's up. We can stop here. Your homework, that will be all the exercise problem behind each section we learn. Okay, so we can stop here. Everybody